Here we have two conducting sheets. The one of them was charged positively, the other one charged negatively, and we have charge per unit area, which is sigma 1, which is positively charged, and then sigma 2 is negatively charged. If you try to compare the magnitude, then you can see that sigma 1 is greater than sigma 2. Now, whatever is pointing to the right side will be the positive, and whatever is pointing to the left side will be a negative electric field. Okay, now let's find what will be the electric field in midway between this, let's say, Q1 and Q2, and what will be the electric field, let's say, here, and what will the electric field, let's say, at point of B. Okay, now how can we solve it? Now, before solving it, we have to draw electric field lines. Okay, first of all, let's take this the sigma 1, the positively charged plate. So electric field will be, as you know, when it's positive charged, it will be outwardly. Okay, so on the right side will be pointing to the right, on the left side will be pointing to the left. Okay, same everywhere. So basically, and what about the red one? The red one will have electric field going towards this negatively charged plate. So we can say that it's going inside of it. From this side is going like this one. Okay, now let's find what will be the magnitude of, I don't know, the electric field at midway between sigma 1 and sigma 2. First of all, let's find what will be the electric field that is coming from positively charged plate. So from positively charged plate, we'll be pointing to the left, right? So I call this one as a E1. Okay, what about electric field at the midpoint for the sigma 2? For that one, again, we'll see that it's going towards the left side. So we can say this one as a E2, right? So that means it's clear that E1 and E2 is pointing to the left, right? So I can say that E total is equal E1 plus E2, right? So what is a general formula to find an electric field when you have these plates of, conducting plates which are charged? So what is the formula? The formula for this one, for the electric field E1, will be what? E1 will be a sigma 1 divided by 2 epsilon naught plus sigma 2 epsilon naught. So this is a sigma 1, this is sigma 2, right? As I said, whatever is pointing to the left side for the electric field will be the negative. So therefore, I can say that sigma 1 is pointing, electric field pointing to the left side at the point of, let's say, A, okay? So therefore, I can say the negative sigma 1 divided by 2 epsilon naught. And what about for sigma 2? For sigma 2 at the point A is again pointing to the left side. So it's sigma minus sigma 2 divided by 2 epsilon naught. Okay, so that's it. If you have a value, so you can plug it and you get the answer. Now, what about electric field at point B? How can we find it? First of all, again, we have to draw electric field lines. For the sigma 1 will be electric field pointing this side, so I call it E1. And what about for sigma 2? For sigma 2, it's pointing to the left, so I call this one E2, okay? So that means you have to find E total. Again, E total is equal E1 plus E2. You have to put the directions, okay, guys? It's very important. So the E1 is equal what? E1 is pointing to the positive one, so therefore I will put positive sigma 1 divided by 2 epsilon naught. And the E2 is pointing to the negative, so I put it negative sigma 2 divided by 2 epsilon naught. Okay, so that's it. Then finally, if you want to find what will be the electric field at point C, okay? So electric field for the sigma 1 will be pointing basically to the left side, so I call it E1, and for the sigma 2 it's pointing to the right side, so I call it E2. So that's it. I think you can just say that E total for the point C is equal negative E1. Okay, so let me just write it down, like first of all is E1 plus E2, then I can put the negative sign, so it's a negative sigma 1 divided by 2 epsilon naught, as 1 is positive sigma 2 epsilon naught. So that's it, I think, guys.